All right, let's just jump right into this explainer. Today, we're going to totally demystify two of the absolute most powerful tools we have for measuring the concentration of resources. Because, whether we're talking economics, demography, or geography, understanding exactly how things are distributed is absolutely essential. We hear the word inequality tossed around literally all the time, right? But how do we actually prove it? How do we measure it accurately without just guessing? Well, that is exactly what we are going to unpack today. Whether it's wealth, income, or population, understanding exactly how unevenly things are distributed requires way more than just a gut feeling. It requires highly specific tools. You can't just glance at a map or a spreadsheet and instantly grasp the true scale of concentration. We need solid, mathematically sound methods to take all those messy raw numbers and turn them into a crystal clear picture of reality. So, here's our roadmap for today. 1. Measuring population distribution. 2. The Lorenz curve. 3. The Gini coefficient. 4. Connecting the two. And 5. A real-world case study looking at Bangladesh slums. All right, starting off with Section 1, measuring population distribution. Tracking exactly how populations and resources are spread out is a massive challenge that researchers have grappled with for literally centuries. Think about it. If a country has 100 million people and a set amount of wealth, figuring out who has what or where people are totally packed together versus spread out is step one for any kind of planning. Well, over a century ago, Max Otto Lorenz gave researchers a brilliant way to visually map out this concentration. It absolutely changed demography and economics forever. In his 1905 article, Methods of Measuring the Concentration of Wealth, he introduced what we now call the Lorenz curve. It was a real game changer because it took all this complex data and offered a way to literally draw a picture of inequality that pretty much anyone could understand.
Which leads us perfectly into Section 2, the Lorenz curve.
Now, this curve is really the foundation for almost everything that follows when we study population and wealth. It introduces our first major concept, which is visually representing inequality. Put simply, this curve helps us see exactly how evenly or unevenly something is shared among a group. And it works by comparing cumulative percentages. Imagine for a second lining up the entire population of a country, right? From the poorest to the richest, or the least populated areas to the most. As you move down that line of people, you keep a running total of the resources they hold. That comparison, population percentage on one side versus resource percentage on the other, is the absolute heart of the curve. So how does it actually take shape? By plotting our cumulative data against a perfectly straight 45-degree line of equality. You can kind of think of that 45-degree line as a hypothetical, utopian world of perfect equality. It's like cutting a huge cake perfectly evenly, where 10% of the people get exactly 10% of the cake, 50% get 50%, and so on. But as we know, in the real world, the data we plot almost always sags below that perfect line, and that sag is what creates the curve. Now, the biggest advantage here is that it provides this fantastic, instant visual presentation of inequality. You can just look at it and immediately see if a curve is deeply bowed or tracking close to the line. But what if you need to objectively rank, say, 50 different countries? That's where things get tricky. Different distributions can actually produce curves that look remarkably similar, or they might even cross over each other, making visual comparisons a bit of a nightmare. Plus, it can't really tell us why the inequality exists in the first place. But its main limitation, it doesn't give us a single concrete number to actually rank things. And that specific limitation brings us right to Section 3, the Gini coefficient. If the Lorenz curve is the picture, the Gini coefficient is the exact mathematical measurement of that picture. It solves our numerical problem perfectly. This coefficient is the ultimate quantitative measure. It gives policymakers one single, hard number to quickly compare different places or time periods. So instead of just staring at a sagging curve and saying, well, yeah, that looks highly unequal, you can calculate a precise value. This is huge because it allows governments and economists to track shifts year over year with pinpoint accuracy. It operates on a very strict scale. It goes from 0, which means absolute perfect equality, all the way to 1, which represents total perfect concentration. So a score of 0 means everyone has the exact same amount. But as that number grows, say into the 0.21 to 0.40 range, you're looking at low to moderate inequality. Once you cross 0.61, you are definitely in high inequality territory. And a 1.0, no way around it, that means a single person or a single region holds absolutely 100% of whatever resource is being measured.
Moving right along to Section 4, connecting the curve and the coefficient.
So how do these two fit together? Well, they're a dynamic duo. Actually, they're really two sides of the same coin. You literally cannot have the Gini coefficient without the Lorenz curve. because the Gini coefficient is calculated directly from the mathematical area between the Lorenz curve and that perfect equality line. Remember that 45-degree straight line we just talked about and how the Lorenz curve sags below it? That empty space, that physical gap between the straight line of perfection and the curved line of reality, that entire area is the Gini coefficient. The bigger the gap, the bigger the area, and the closer your Gini coefficient gets to 1. Let's bring this into the real world with Section 5, our case study on Bangladesh slums. We're going to put this theory into practice and see how human populations are actually distributed across 8 divisions in Bangladesh. Specifically, we're looking at the spatial concentration of the slum population compared to the total population. First up, we arrange our raw data in ascending order based on the ratio of slum dwellers to the total population. We start down at the bottom with Mymensingh and go all the way up to Dhaka at the top. To put this in perspective, the total population of Bangladesh is over 165 million, and the slum population is about 1.7 million. But, spoiler alert, they are not spread out evenly. Mymensingh has the lowest ratio, so it ranks first. Dhaka has the highest, so it sits at rank 8. Then we just figure out what exact percentage of the country's total population and what percentage of the total slum population lives in each of these specific divisions. Next, we calculate the cumulative percentages for both of those populations. We just keep a running total, adding each division's share step by step until we hit exactly 100% at Dhaka for both the total population variable, which is our x-axis, and the slum population variable, our y-axis. Once we've got those cumulative coordinates, we plug them right into our formula to find the precise area between our real-world data and that hypothetical line of perfect equality. And after crunching all those numbers, our final Gini coefficient comes out to exactly 0.343. Or, if you're a percentage person, 34.3%. Keep in mind our scale from earlier. 0 is perfect equality, and 1 is total complete concentration. And here's what that looks like visually. You can clearly see that orange curve dipping down below the blue equality line, which completely confirms the uneven distribution. Just look at how those orange dots, which are our calculated cumulative data points for the regions, pull away from that straight 45-degree line. That blue shaded area trapped between the straight line and the orange curve, that perfectly represents the 0.343 Gini coefficient we just calculated. It's literally seeing the math come to life. So what does a Gini score of 0.343 actually tell us? Well, we know this falls into the moderate inequality range. It proves that some dwellers are highly concentrated in specific urban centers, like Dhaka, rather than just being spread evenly across the whole country. In fact, if you really dig into the data, Dhaka holds over 26% of the country's total population, but it accounts for a staggering 50% of the entire country's slum population. That's a massive concentration. On the flip side, divisions like Mymensingh, Barishal, and Rajshahi have comparatively way smaller shares of the slum population relative to their total size. These mathematical tools perfectly diagnose the reality on the ground. So now that you know exactly how to decode the concentration of resources, it really makes you wonder, right? What hidden inequalities might these tools reveal in your very own backyard? Whether you're mapping out local coffee shops, neighborhood income brackets, or even public parks, the Lorenz curve and the Gini coefficient give you the power to uncover the mathematical truth behind the world around you. So, what are you going to measure next? Keep questioning the data, and we'll see you in the next explainer.